and thank you very much for the opportunity to present our results on wildfires in the Arctic today here. So, as introduced, joining me in this work has been Jessica McCarty from NASA, and like I said, she's online here. And also Anna Lipsanen is myself from SUGET. So I will be talking about the Arctic fires and boreal fires, how we are assessing them today, and then what the future of fires looks like. All of this is, like Russell said it before, this is going to be in a technical report that will be published maybe already in this month, but by the end of the year, the latest. And the title of the report is same as this presentation: the Arctic fires, the present estimates, and future pathways. And to set the scope, we're talking about wildfires, so forest fires, grassland fires, etc., and agricultural burning. And the geographical scope is the Arctic country member states and the Arctic and boreal areas, basically. That's what we're looking at there. So the report is divided into two parts, and so the presentation will be as well. First of all, I'll be talking about how we assess the fires, and in more detail, looking at how national inventories, initial inventories on burn area estimates, how they differ from independent estimates, usually more for research, which are based on satellite observations. So they give a little bit different results, but I will give a little bit details on why this is. And we have some recommendations for reporting and monitoring of these fires. The second part of the presentation will be on the future of the Arctic fires. And we have created pathways for the different pathways for the future in help to assess the future emissions of the fires. And there we have been concentrating on the human activity impacts, like policies, fire management, these kind of factors on these fires. So first of all, looking at the national inventories of the fires that the countries themselves gather, and then how the burned areas that they report in these statistics, how they compare to satellite observations and independent inventories developed from these observations. So they don't give exactly the same numbers. Here are some numbers, few years, different years for the Arctic Council member states. And the main point here in the middle is the official estimates from these national inventories. And then there's the Global Wildland Information Systems, GWIS, burn area estimates to the right of them. So on the orange color, we see countries where this GWIS in the inventory gives an overestimation of the burn area compared to these official inventories. And on blue, there's the ones in which it gives an underestimation. There are a few different reasons for this. So the problem here, of course, is that, first of all, like I said, the numbers don't match, but also there's not a systematic difference. We don't always give overestimation or underestimation. It goes both ways. If we look first at where the underestimation happens, so basically Canada, US, the Alaska side of the US, Sweden, Denmark, and especially Greenland. One reason for this is that the satellite observations are, of course, prone to be blocked by clouds or sometimes smoke. And then there's understory burns, which are not detected as efficiently with these satellites as they are on ground, maybe where these official statistics are gathered. So this might lead to this underestimation, so basically the missing some fires. But then there's the other side, where we actually see overestimation, and like looking at Norway and Finland, there's actually a huge overestimation if we compare to the official inventories. And in here, it's also with technical reason for this. So these satellite observations, when they detect a fire, they can detect quite small fires, and especially in Norway and Finland, fires are usually really small. They might detect this, but the resolution of the satellite observations, there's a limit to that. And for example, quite often it's can be 500 times 500 meter pixel. And if the satellite sees and detects a fire in this pixel, it is usually these independent inventories assume that the whole pixel is burned. But in fact, these fires are usually so small that this is not the case, and this leads this overestimation. And looking at the percentages, of course, the numbers are really huge. So there's also another aspect that to highlight is on the differences between these two types of estimates. So the official statistics, they are collected with the fire management in mind. So how to allocate resources in fighting the fires, what kind of impact it has on economy, for example, forestry, how human settlements, human health, how they are in danger of these fires. So this is kind of the angle that they come into fires, and they are usually collected by, or at least the responsibility of the ministry or agency which is collecting them. On the other hand, these so-called independent inventories, so and here we're talking about global fire emission models, they usually are optimized with a specific aspect or several aspects in mind. For example, they could be developed to improve the burn area estimates themselves, also aerosol estimation or atmospheric chemistry. So more on the emission side and how they are impacting the climate and health, but also how they transport it in the atmosphere, etc. So kind of like the way they're looking at the fires is a little bit different, and that will cause also some of the differences between these two estimates. But even with these differences, these independent inventories can be used to discern trends in these fires in the Arctic and these extreme events, what are the trends in them throughout the years. So a few recommendations that we have in our report for this report and monitoring of these fires. But first of all, the countries collect already very good data actually on the fires, and how the fires have been put out, etc., etc. The problem is that this data is not always readily available. So the countries could share the data in a common formats and open it as more as an open data, especially from the research side. This would be very helpful. But not only for the research side, also to plan these different types of fire management strategies, and they could be which could be shared throughout the Arctic, and to support this kind of development, kind of like these best practices that could be then shared throughout the Arctic states. We propose a general standardized fire size classification system for the Arctic and boreal fires. So basically, it will be just to classify the fires small, medium, large, and very large. Don't have time to go into details here. You can see more in the actual report. But the point is, it would enhance the understanding of the relationship between the different ignition types and fuels and ecosystems that are usually burning, and the emission frequencies and different management strategies, and to develop and share these with each other. And finally, the satellite and modeling methodologies need to be developed further, which is of course always the case. But this would assist in detecting and characterizing these events, especially we're looking at the extreme fire events in the Arctic countries. And the thing is that the new satellite products, they already exist, they are there, but they produce such a huge amount of data that we would need a lot of labor and also a lot of computation power to actually produce this data. So more resources are needed here to utilize this data efficiently. Then moving on to the Arctic fire pathways for the Arctic. So just as a background in here, so what I'm going to be talking about is how the human activities, policies, etc., how they impact, how humans impact these fires and can impact the fires in the future. But always in the background, there is the fact that climate change is increasing and will continue to increase both the fire activity and fire risk throughout the Arctic. The human activity is the main cause of the fires in many places already. And one common development we mentioned here is that this is affecting the wildfires throughout the Arctic, that there is an expansion of agriculture, expected expansion of agriculture further north, especially in Russia. So this is kind of background which is behind all these pathways that I'm going to present. So we have three pathways that we have developed. First of all, so-called we got this pathway, which is the lowest fire activity and lowest fire risk pathway. So even in this pathway, there are still fires happening, but in really controlled manner, and the risks are handled well. So we have enough resources to do a lot of prescribed and cultural burning, which is also a way of managing the fires. The attack rate of wildfires is good. Agricultural burning is banned. It is actually already banned in many places, but those bans will be enforced much more readily as we speak. Then there's a lot of urban growth, and this wildland urban interface affects the fires heavily. So these could be kind of addressed with different policies. And in this pathway, we also expect like the population growth to stabilize. And one more thing to highlight maybe here is like there's more green energy and less production and extraction of fuels, especially fossil fuels from the Arctic. As said, behind here, we assume that climate change will increase the fire risk, but we are not here considering different climate future. We are focusing on human impact on fires. Then there's the other end of the spectrum kind of thing. So let it burn pathway, as we call it, the highest fire activity and fire risk pathway, where there's limited resources actually to attack the fires. There's limited resources for fuel management and development of different policies to handle these fires. And tourism increases maybe more than the different pathway, and there's new people then going into for example, to the wildland and using fire, but they're not guided. How do you do it in a safe way? So this is the other end of the spectrum where we have a lot of fires, and there's big fire risk and big risk all the time for bigger, like huge fires, extreme fire events, and well, of course, bigger impact on society and human health and the nature as well. And the third pathway that we have created is the so-called fire will come. And like I said here, individual best guess fire pathway. Individual means that because the previous two pathways were created and considering Arctic as a whole, but these are created for each Arctic state individually. And the best guess means that this is based on our expert judgment and expertise on this fire. So we think which is right now kind of the most likely future. And when we're talking about the future here, we're talking about until 2050. In this best guess pathway, we have selected here the main factors for each region. And there you can see the line. You see my pointer there. I'm not sure if you can, but so we put the kind of like our assessment between these. We got this, the lower fire risk pathway, and the let it burn, the higher fire risk pathway. How we think these different factors can be addressed in different regions and in this best case pathway. For example, in the Nordic countries, like stated already, human caused fires is the main ignition source for the fires. But we think that in the Nordic countries, the society is rather strong, the policies are easily effective. People kind of believe what the officials tell them. So in this case, this challenge, there's a good chance that will be addressed efficiently in the future. On the other hand, we have Eurasia, so basically Russia. Right now, it doesn't seem like the society over there have a lot of resources and capabilities to address these increasing risks on wildfires. And we have highlighted Greenland here as its own area and a new region. And Greenland, well, it didn't used to really have fires that much, but it is an emerging fire regime in the Arctic. They have already had some fires, and it is kind of lying in between the Nordic countries and North America. It has some similarities to both, but it is its own thing, basically having its own characteristics. And like I said, we have created these pathways for each country separately. Again, here I'm just going to present how we think these the most likely pathway will be in relation to the We Got This and Let It Burn pathways for each country. It's not to go too much into detail because time's really limited here. You can find more in our report. But basically, looking at it, there's going to be some countries which are more readily capable of addressing this increasing fire risk. For example, Greenland, Iceland, Norway. And then again, Canada, United States, Russia, of course, huge areas that they will also control, and they're going to have larger challenges in regards to the Arctic fires, and probably going to see more fires in the future. Quickly, just a few recommendations for the Arctic emission scenarios that are included in our report. So the point and the goal is to create emission scenarios for these fires for the future. In order to do this, we have looked at how human activity impacts the fires. This needs to be combined with the climate change impacts to create the actual scenarios to get comprehensive data sets for the future. We are aiming to create these emission scenarios that go up to 2050 and creating a spatial data set, which means basically putting these fires also on map. And lastly, while this report, we're talking about Arctic and boreal fires, but other regions need similar kind of assessments in order to create global fire scenario to be comprehensive. But different regions have their own characteristics, so they need to be treated separately so that we can get really high quality scenarios for the future. Arctic area has been kind of lacking in the wildfire scenarios. So thank you very much. Like I said, we have this technical report coming, which is in much more details. So thank you very much for the opportunity to share our results with you and report. And as a final kind of advertisement, we actually have an Arctic Fire webinar coming next Monday. But there's still a chance to register for that. And maybe the easiest way is to go to the ABC-iCAP website and find links over there. Thank you very much.